Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. So today we'll be discussing why the depth of the beam is always greater than its width. So here, in order to understand this concept, I have taken a pictorial representation. So here you can see that a person standing on a wooden plank with the same geometrical dimension but different orientation. So, first pictorial representation shows that the person standing on the width face, and second pictorial representation shows that the person is standing along the depth face. So, here we can see that the person who is standing on the width face is having lesser sag or lesser deflection compared to that of the second case. So, in order to have the clear understanding of this concept, so we need to understand the concept of deflection. So I have just considered a simply supported beam wherein it is subjected to the external load of magnitude equal to W. So due to the sag, delta is the amount of deflection. So always whenever the beam is loaded, so it will be subjected to deflection. So due to the deflection, there will be occurrence of the moment. That moment is called as bending moment. So due to the creation of the bending moment, there will there will be creation of the bending stress. So always the bending stress is dependent on one of the important factor, which is called as flexural rigidity. So flexural rigidity is nothing but it is a product of EI. So where E is the Young's modulus and I is the moment of inertia. So the product of Young's modulus and moment of inertia is called as flexural rigidity. So which is always directly proportional to the bending stress. So bending stress is directly proportional to flexural rigidity. In turn, so bending stress is also called as moment resistant capacity, or it is also called as strength of a material. So in other words, always strength of a material is gauged by its flexural rigidity. So this is a simple statement. So and one more thing is that E, that is the Young's modulus, is always material dependent, and I, the moment of inertia, is always geometry dependent. Means whether the cross section is rectangle, circular, or square, based on that, moment of inertia will be dependent, and based on the material, whether it is mild steel, or copper, or brass, or aluminium. So, based on the material given for an object, so Young's modulus is dependent. So I can say that so moment resisting capacity or a Young's modulus is always directly proportional to the moment of inertia, because Young's modulus will be constant throughout, but the varying factor will be the moment of inertia. So therefore it is proportional to the moment of inertia itself. So next, in order to have a better clarity of this concept, so I have came with this numerical. So wherein I have taken a cross section of a beam with the width equal to 250 mm and depth equal to 400 mm in the first case, and second case is reversed, where B is equal to 400 mm and depth is equal to 250 mm. So here I need to calculate for both the cases. I need to calculate what is the moment of inertia for both the cases, since it is a rectangular cross section in both the cases. So moment of inertia will be equal to B d cube by 12. So horizontal dimension into vertical dimension cube divided by 12. So in case 1, B equal to 250 and D equal to 400. So it will be 250 into 400 cube divided by 12. So I value, that is moment of inertia value, comes on to be equal to 1.33 into 10 power 9 mm power 4 upon simplification, and in case 2 it comes on to be 5.2 into 10 power 8 mm power 4. If we just visualize this results, so I for case 1, that is a moment of inertia for case 1, is greater than um, case 2. That means that um always moment of inertia is dependent on the depth of the cross section. If the depth of cross section is more, moment of inertia is more. So if moment of inertia is more, moment carrying capacity is more. So if the moment carrying capacity is more, so the strength of the material will always be more. So therefore we need to have the depth of the beam should be always greater than the width of the beam. That means, in simple words, so always the depth of the beam or the beam should be placed with depth greater than that of the width, so that it will be having more resistance towards the applied external load. Thank you for watching. Please like, share, and subscribe the video and support us.